My name is Ronald Nomberg. I'm currently associated with the Pacific Northwest National Laboratory. I'm sitting here with my colleagues from the FFTF project, or Fast Flux Test Facility project. That project was a design-build project, one of the most successful projects in the recent history of the Department of Energy. We gathered together this particular group of people because they represent different management levels in the FFTF project. We have a representative of our client or customer, the Department of Energy here. We have a senior manager from the FFTF project, and we have, similar to myself, the middle and lower level managers who implemented the direction of the senior manager and the client. And we've organized this such that we can talk about, in a design-build project, the design, the build, the acceptance testing, and the turnover. And now I'd like to ask my colleagues to introduce themselves and say a little bit about their background and participation in the project.
Well, my name is David Polzine. I came late to the FFTF. During construction, I actually came in the summer of 1981, right toward the end of construction, and joined test engineering as a field test engineer. I was involved in running a number of tests, acceptance tests on the reactor itself, and took on the project of formally closing out the acceptance test program there at FFTF. Later became manager of mechanical equipment engineering at FFTF, and followed the FFTF through its operating cycles into various stages of warm and cold and other layups, and then through shutdown, and as of about a year ago finally closed the doors on FFTF and locked them up and shut everything down.
My name is Alan Walter. I came to the project in the late 60s, and even though I was here during the construction, my main role really was involved in the regulatory process of FFTF. It was a DOE facility, as Ron indicated, and as a consequence did not require licensing from the Nuclear Regulatory Commission. But at that time, the feeling was that fast reactors were going to be built in large numbers because there was a concern that the uranium supplies were going to be depleted and we would need the fast spectrum, the breeder reactor. Therefore, the Department of Energy decided that they would like to have a complete review from the Nuclear Regulatory Commission for two reasons. Really, to make sure that this kind of a reactor could be licensed, and then secondly, to build up the staff at the NRC in anticipation that there would be many more reactors like Clinch River and follow-on. Therefore, my main contributions, if there were any, were really to work with the Nuclear Regulatory Commission, the Advisory Committee on Reactor Safeguards. And we worked with the preliminary safety analysis report, the final safety analysis report, and then after the reactor went critical, my main responsibility was to work with the fuels and material specialists to really glean the reason that the reactor was built, to test materials. And then finally, near the end, we actually did some very interesting safety tests before the reactor was shut down, which are still world-class.
My name is Chuck Carlisle. I'm a retired naval officer. I retired from the submarine service in 1972 and was hired by the Atomic Energy Commission and came out to the FFTF project as a site representative, senior site representative. Then when the FFTF project office was formed to carry out the project, I became the deputy director for operations in the project office and carried that on through during construction and turnover testing. And then during the final stages of construction and startup, I took over as director of the project office to see the project through to completion.
My name is Bruce Nordoff. I began my nuclear career with Admiral Rickover's program in Pittsburgh and spent 19 years there in various roles. In 1972, I was released to come to Hanford, and my first involvement in the FFTF was to assist in the Hanford test program on equipment and systems for the FFTF. In 1975, I was brought into the new project as it was updated, and I became the startup manager of the project and carried the plant through startup testing, sodium fill, initial criticality, full power. I became the first plant manager of FFTF, and I concluded that and moved on to another assignment in 1982. So my remarks today are going to be based upon the latter half of the project. The project was designed before I joined in. The construction was well underway, and I got into the tail end of the construction and the full startup and operation of the plant. My role was to form an operating staff, a program staff of maintenance people, test engineers, operations people, and have it be a disciplined organization which met the requirements of the project as outlined by Chuck and others. So I was a guy that they used to call Darth Vader at times, because I had to make sure we had the right discipline in the organization. That's all I have. Thank you.
As you can see from our distinguished colleagues here, both the Department of Energy and Westinghouse brought the best of their best to this project. Chuck represents a good deal of history in the department and in naval reactors. Bruce represents the senior management philosophy and thought of Westinghouse. We generally did what the department requested and what Bruce requested and demanded and directed of us. And we have gathered together 7 different topic areas, that we think would be useful for anybody who engages in a design-build project for a reactor in the future. And we would like to talk to these one at a time. I'll introduce the general area, and our client at that time, our customer at that time, Chuck Kyle, the director of the project office for DOE, will say a few words about the area, and our colleagues here in Westinghouse will contribute from their knowledge and experience insofar as how we implemented each topic area. So let me begin by saying the first topic area is design and engineering, and let us ask the client to define that area a little more fully for us.
The success of the project can be attributable in part to the general excellence and discipline exercised by the Atomic Energy Division, Reactor Development Division, and Reactor Development Division Technology, Westinghouse, and other major contractors. By way of a little background, the FFTF conceptual design was first developed by P&L during the 1960s. When the fast breeder reactor program, which was alluded to earlier, came into being under the AEC, with the intent of producing a series of fast breeder reactor power plants, the need is established for a materials test reactor to support that development. And they chose FFTF to do that. It was taken over by AEC and brought along then as the materials test reactor in support of the Clint Streeter breeder Proctorite and subsequent FFTF or subsequent FBR programs as they developed.
And the order in which we'll talk after hearing from our client here, our customer, will start with the senior manager from Westinghouse, Bruce Nordhoff, and add to what he says, and then proceed down the table to the people who actually got the work done that Bruce Nordhoff requested.
There may be some which the reverse order might be best. Taking the first one, design and engineering, my comment, my views towards how a project should be conducted in the future would be to make sure that the contract people, that is the government people, the DOE or AEC people, are technically strong. We benefited mightily, very strongly, by having a project staff of strong people who could enter our discussions, our planning, and make contributions, technical contributions. They were key to our having the ability to move forward in the project, help us make these decisions. They were not administrators. They were technical people who were mighty savvy. I was used to that under Rick over in the Pittsburgh area, and it was true that when I came out here and found that same way, that same strength there, that was a happy day for me.
So it is in fact quite true that the customer staff were technically very strong. They participated in meetings with us. When we worked every day, the direction that was given to the customer staff was identical to the direction that was given to the Westinghouse staff. And we talked about how we would implement it and didn't really have any disagreements over what our general direction was. And so now I should let Alan Walter and Dave Polzin talk to their experiences working in that environment.
Well, let me just start with a perspective. This was a time when, as Bruce indicated, and I think Chuck alluded to this too, in the country, we were concerned about energy. There was a general upbeat feeling toward nuclear energy in the 1960 time frame. The U.S. was clearly the leader. We developed the technology in the United States with a lot of brain drain from Europe. But nevertheless, nuclear power was widely accepted by the public. And we were concerned, we were starting to build reactors quite rapidly. There was a legitimate concern that we were going to run out of uranium. And therefore, we needed the fast spectrum breeder reactor because that would leverage us from perhaps a few decades of nuclear energy to literally millennia. As a consequence, there was a sense of euphoria. And when this project landed here, I know I can speak for myself. This is where I wanted to be. I had 10 job offers out of college, and I came here and said this was it. I wanted to get on the ground floor, and I think a lot of people felt the same way. Westinghouse was clearly one of the major leaders, and that's what brought Bruce and others out here. This was the place to be. My point is that you start with people. People, it's human resources that make something happen. Sure, we can get direction from Darth Vader here. It was good direction, I might say. But the point is people wanted to succeed. As Bruce pointed out, it was the DOE people, AEC people, they wanted to succeed. So it wasn't a matter of a tug and war sort of thing. It was let's build this and build it right because we were at the threshold of a brand new technology that literally was going to have implications for millennia. So I just think that it was important to recognize you start with people. And we had the best people, frankly, that the U.S. and to some extent the world had to offer. And therefore, it made things work.
Well, from my viewpoint, I came here from the naval nuclear business. I spent 9 years in the naval nuclear business within Westinghouse, buying equipment for the Navy, and so had ingrained in me. I've worked engineering all my life, and had ingrained in me through that program to the level of detail and the follow through and documentation of things as you got them finalized. And I must say that FFTF is probably one of the most well-documented reactors in the world, possibly. We have in excess of 65,000 drawings, and in comparison, the Hanford site only has about 115,000, so we have over half the drawings for the whole Hanford site, and represent a very small portion of the Hanford site. So it is a well-documented facility, and coming here from the Naval Nuclear Program, which is also a very well documented program, I was happy to find that that was the case, and we kept drawings and things up to date. As systems changed in the field, we made sure that those drawings were kept up to date, all the changes were made and documented that way. Engineering was divided when I came here into basically three elements, I guess I'd say. The system engineers, or the design authorities for the system, who had the overall responsibility for how the system worked, how that transpired. And then we also had, to help that whole system out, we had component engineers that had very detailed design knowledge of the components themselves and how they interacted within the system. And so that helped an awful lot. I came here and joined test engineering, which was kind of an ad hoc group that did all the field testing and wrung out the equipment, so to speak. Our responsibilities were to actually take the design parameters for the equipment and, if at all possible, test that equipment up to the design requirements, which in most cases were far above what the equipment would operate at. And so we did that and found whatever problems were there and tried to get those ironed out. So I think a combination of all those aspects of engineering really entered into making this a very good facility, making the equipment work and making it last.
That leads into our next topic here, and I might add one point, and that is on the FFTF project. We had what was called a cognizant engineer. He was a cognizant engineer for a system, abbreviated COG engineer. And throughout the project, the cognizant engineers had a lot of respect. They were the people who understood their system thoroughly. And Dave alluded to that, and to the component engineers.